Saxon Algebra 2, Lesson 114. Welcome to the world of nonlinear inequalities. That's a fancy name for a much simpler idea. Let's consider a graph. And let's put a line on our graph. I know this says nonlinear, but bear with me. Let's say there's a line that looks like that. Would you agree that we could divide this arrangement into three areas? Up here, there are a bunch of points above the line, and I just gave it away. These are all points above the line. Down here, there are a bunch more points. I'm going to represent them with squiggles because I want to make a distinction between the two. These are all points below the line. And along this solid blue line, these are points on the line. Three different regions, if you will, three different sections of our Cartesian coordinate system. Just by drawing a line, we create these three unique groups: above the line, below the line, and on the line. What we can say is that in this place, y equals mx plus b. Watch this. These are generally y is less than mx plus b. And up here we say y is greater than mx plus b. So we can describe these three regions with the equation of the line. I'm not putting numbers in because I don't want to get caught up in numbers yet. We're not thinking about numbers, we're just thinking about these areas. The line itself is where the y is equal to that. Down here, y is less than, and up here, y is greater than. Okay, so we can graph inequalities pretty simply by creating different combinations of these three symbols: the greater than, the equals, and the less than, right? And we're going to do that in just a minute. We've already done that, haven't we? We've done that with lines. Now we're going to do it with different shapes. So let me show you how John writes these problems. We've done this, linear inequalities. What we're going to do differently today is we're just going to use some different shapes. Okay? So we're going to use these same ideas, but with different shapes. And these problems are nice because you don't have to draw these in your homework. But it's helpful to show them for what we're doing. Excuse me. So what John's doing is he's saying, we're not going to limit this to just lines. I'm going to draw a parabola in here. Mine's not as neat as I'd like it to be, but pretend. And then what he does is he labels the regions. And this is where students can initially get confused, but after you see a few of these, you'll understand. John is he's using these letters to define 4 different regions. Notice that we have this shape. I'm going to make these a little bolder. And this shape. Those are our 2 shapes that we're dealing with. It says nonlinear. Only one of ours is nonlinear. The other one is a line. But do you see that just like a single line will divide into different areas, these are dividing our space into different areas. Area A is the area above the line and outside the parabola. Above the line, but outside the parabola. Above the line, but inside the parabola is B. Below the line and outside the parabola is C. And below the line and inside the parabola is D. That's the hardest part of these problems, I promise you, or at least I think it's the hardest part, is just trying to track on how these letters fit with the picture, right? Okay, so what John's asked us to find is the area where y is greater than or equal to minus 1/2 x minus 1 and we do not, this is the system of inequalities that has been graphed, and we're trying to find the right regions for these inequalities. We want the area where y is above the line. This, John tells us, is the equation of a line. And this inequality is telling us that we want the region above the line. Okay? This, John tells us, is the parabola. I'm going to write that down here because I don't have room on the side. And this tells us that we want the region outside the parabola. Okay? If it was less than, that would be inside. We'll get to one of those later, I think, in the examples. How many examples do we have? 1, 2, 3. All right, so we want the region that is above the line and outside the parabola. That would be region A. But we want to test it. Again, I think I've had the same conversation with you. The easiest test point to use, okay. Let me write a bunch of stuff and then I'll explain it to you. Okay, freeze me if you need more time to write that, because I'm going to talk about it now. So freeze me and come back when you're done. The test point can be any point in or out of the desired region. Let me rip out my page so I can show you. The test point can be anywhere. The important thing is that if I choose a test point that is within my desired region, that where I think the answer is, which is right here, if I choose any point in area A, then it should be true, right? If my theory is correct, then any point should make these two inequalities come true. That's what the test point does. We plug it in for X and Y, by the way. If I choose a test point within the desired region, or the suspected region, I guess, then it should be true. But if I purposely choose a test point that is not in the desired region, which I'm not sure why you would do, but you could do it. If I chose a point down here, then it should be false. That would give me comfort. If I chose a point down here and it was false, I would say yay. Better to choose a point that you think is going to be true, right? Pick a point in your region. That makes more sense. is to choose a point in your region, but if you choose a point that's not in your region, that's okay. That will tell you something, and it should be that you get a false answer. So that's the thing about test points, is that you get to choose it, but where you choose it will affect what kind of result you're hoping for. This is what we prefer. Choose a test point that is within the region that you think is the right answer, so it's inside the desired region. That is what you prefer. And the other thing we prefer is, if at all possible, use the test point of 0, 0, because it's easiest to do the math. That's the only reason. It's just easiest to do the math. So I like to use 0, 0 whenever possible. Now, we need to use a test point for this problem. And I can see 0, 0 actually will be good because it's in my desired region. So I'm going to use the test point of 0, 0. That means I'm going to take my two original equations and I'm going to fill in this point for those x's and y's. So the first one will be 0 is greater than or equal to minus 1/2 times 0 minus 1. Okay, so this is, I'm going to call it A and B. So I'm testing the first inequality. I've filled in 0 for the x and y, and now I'm going to simplify. This all goes to 0, and it tells me that 0 is greater than or equal to 0 minus 1, which is minus 1. That sounds very true to me. Okay, so we've got the first one done. Now we'll plug it into B. It should be true for both of them, right? 0 is greater than or equal to minus 0 squared plus 4 times 0 minus 1. Okay, so I plugged zeros into the second one. All right, and set that aside for now. This all comes down to 0. This all comes down to 0. 0 is greater than or equal to, let's see, 0 plus 0 minus 1. Again, true. So the test points bear out my hunch, my educated guess that region A was the right answer. John, do you agree with me? John does. Yay, John agrees. Beautiful. Okay, let's do another one. How many are there? Just 2. Oh, no, there's 3, sorry. Example, there's something in the, oh, it's the edge of that. Example 114.2. Again, I'm going to draw the picture just so we can talk about it. You do not need to draw the picture in your homework. This time we have equation A, which is a parabola. John tells us this. I'm not telling you this. And we have B, which is a line. The parabola we'll need those to plug in for testing our point. Let me show you the regions because I haven't done that yet. Again, you do not need to copy for your homework, but it's easier for me to explain. I'm just going over these so you can see a little better how the different regions are divided up. All right, we are looking for y is greater than x squared. Now, in this case, let me go back to our old problem. Our parabola was facing down. And so y was greater than the equation when we were outside, right? Because that's where the y's could go up. Down here, the y's are getting smaller, right? The values are decreasing. Up here, the values are getting greater. So the values. So when we say we want y greater than, then that means we want to go up here, and that's outside of the parabola. Here we have an upward facing. So the rules change. And that's kind of good because I don't want you to depend on the rules. I want you to use common sense. Here, if we want y to increase, we're going to be inside the parabola. Okay, so with an upward facing parabola, the greater values for y are inside because here's where it's going up. All right, so that means we want inside the parabola. The line, we want them to be less than y. So this is below the line. All right, so let's see. We want inside the parabola but below the line. That's looking like region C. So we'll write that down as our educated guess. Oh, my cat's throwing himself at the windows. Hi, Tuna, you want to come in? Okay, pause. Sorry. Come in, little man. Sorry for the interruption. You know I love math. You know I am devoted to teaching you. It means a lot to me. But you know what? When my adorable little black cat is standing outside in the flowers, there's little blue forget-me-nots blooming in my garden. So there's my little black cat with his shining green eyes looking up at me in the window saying, please let me in. I'm sorry, I just have to do it. Okay, so we think that this region is a good guess for our solution. Now, we can see that the origin, my line got a little here, but the origin is outside of region C. So I'm not going to use that as the test point. I'm going to choose a different test point because I don't want to choose, I would expect it to be false if I use the origin, right? Because it's outside of my desired region. So I could use that, but I don't like that. I would rather get a positive result than try to get a negative result. So I'm not going to use the test point for this one. I'm going to choose a point that lies clearly within here. And you can see in the diagram, I'll show you. In John's diagram, he chose this point, -2, +1, as a point that is clearly sitting right in the middle of region C. So let's use his point. -2, +1. All right, I'm going to rip this out so I can take these equations to the next page. And we said it was -2, +1. All right. And then here are, I'll fold. Here are my two equations, right? So for A, 0 is greater than, okay, I'm not even going to write it all out. X squared, that's just 0. Oh no, shoot, I'm not using 0, 0, right? How quickly I forget. So my test point is 1 is greater than 2 squared plus, oh, it's -2. Right? It's -2. Make sure you put it in buckets or you'll get the wrong answer. And then it's 4 times minus 2 and then plus 2. Okay, so then this becomes, this is 4 minus 8 plus 2. And this is 1 is greater than 4 minus 8 is negative 4 plus 2 is negative 2. That is true. Okay. And then B, 1 is less than minus 2 plus 1. This becomes a positive 2, so that's 1 is less than 3. That is also true. So my test points prove that region C is a winner. And John agrees. All right. Last one. Example 114.3. Now I'm going to do this one as I would suggest you do it in your homework. You do not have to copy the diagram into your homework. That's a lot of work. Okay, which region satisfies the system of nonlinear equations? All right, circle and a line. There's the circle, there's the line. Okay, A, B, C, and D. That's pretty straightforward, right? Now, let's see. Here, the x squared and the y squared are less than 16. That is a pretty good hint to us that they lie inside the circle. Okay? We want the numbers that are smaller than 16, and that means inside. And then we want y to be greater than x, so that seems like above. So I'm guessing it's region B. Okay? So that's my guess. I'm going to write that down in just a second, but I want to show you something else. Do you see this one? The line goes right through the origin, 0, 0. I don't want to use the test point for this one either. I don't want to use the origin for the test point because, no, it'll be too confusing because does that mean above or below? It doesn't, it's on. So no, that's too ambiguous. We don't want to deal with the origin because it's not going to give us a clear answer. So John, again, he chooses this point here. He chooses negative 2, positive 2. I'm going to be a rebel. I'm going to choose this point, which is 0, 1 as my test point. So all you have to do on your paper, 0, 1 is what I chose, right? Yes, and I'm just double checking to make sure, yeah, that does look like it should fall in. We guessed it was region B. So I write down, that's the first thing you need to write down is your guess of region B. Then I do my test point. Now, P.S., let's just say you guessed wrong on the region and you chose a test point that you think should be in that region, but when you go to test it, you get a false. If you've done your math correctly, what that means is that you guessed wrong, right? If you thought your point should be true, but you correctly calculated it and you got a false answer, then that means maybe your region's wrong. So go back and look at that again, okay? Sometimes with the region, like this one with the circle, you might feel like you're kind of guessing, right? Because you might be like, I don't know, does it mean inside the circle? Does it mean outside the circle? Just make your best guess. Don't beat yourself up about it. And then use your test point to validate that. And if you get a false answer from a test point that should be positive, then that may mean you guessed wrong. Go back and look. Okay, so now I'm going to use the equations, which what I'm doing is I'm plugging my test point into these two equations. I'm not going to copy them over. So it will be x squared, here's A, x squared is 0, plus y squared is 1. Those should be less than or equal to 16. Yeah, that looks good, right? Because this is 0 and this is 1. So this is 0 plus 1 is 1. That is true. B, y1 is greater than or equal to x, which is, I'm sorry, I shouldn't write x, I should write 0. Yay, it's also true. So that solidifies my region B. So for your homework, study the picture, write down your best guess, choose a nice test point, and then show that work. Most students, once they get the hang of the diagrams, find these kind of fun because it isn't a lot of calculation. And it feels different, right? Sometimes different, especially when we're in the month of May and we only have a few weeks left. It feels good to do something different. Okay, thank you. Goodbye.